The Alpha Clip, a clip model, focusing on wherever you want. Contrastive language image pre-training clip plays an essential role in extracting valuable content information from images across diverse tasks. It aligns textual and visual modalities to comprehend the entire image, including all the details, even those irrelevant to specific tasks. However, for a finer understanding and controlled editing of images, it becomes crucial to focus on specific regions of interest, which can be indicated as points, masks, or boxes by humans or perception models. To fulfill the requirements, we introduce Alpha Clip, an enhanced version of Clip with an auxiliary alpha channel to suggest attentive regions and fine-tuned with constructed millions of RGBA region text pairs. Alpha Clip not only preserves the visual recognition ability of Clip, but also enables precise control over the emphasis of image contents. It demonstrates effectiveness in various tasks, including but not limited to open-world recognition, multimodal large language models, and conditional 2D/3D generation. It has a strong potential to serve as a versatile tool for image-related tasks. AnimateZero video diffusion models are zero-shot image animators, large-scale text-to-video (T2V). Diffusion models have made significant progress in recent years in terms of visual quality, motion, and temporal consistency. However, the generation process is still a black box, where all attributes, for example appearance, motion, are learned and generated jointly without precise controllability other than rough text descriptions. Inspired by image animation, which separates the video into specific appearance and corresponding motion, we propose AnimateZero to reveal the pre-trained text-to-video diffusion model, referred to as AnimateDiff, and provide more precise appearance and motion control abilities. For appearance control, we utilize intermediate latents and their features from the text-to-image T2I generation to ensure that the generated first frame matches the given generated image. For temporal control, we replace the global temporal attention of the original T2V model with our proposed positional corrected window attention, which ensures that the other frames align well with the first frame. Empowered by these methods, AnimateZero can successfully control the generation progress without further training. As a zero-shot image animator for given images, AnimateZero also enables multiple new applications, including interactive video generation and real image animation. The detailed experiments demonstrate the effectiveness of the proposed method in both T2V and related applications. GenTron, delving deep into diffusion transformers for image and video generation. In this study, we explore transformer-based diffusion models for image and video generation. Despite the dominance of transformer architectures in various fields due to their flexibility and scalability, the visual generative domain primarily utilizes CNN-based UNet architectures, particularly in diffusion-based models. We introduce GenTron, a family of generative models employing transformer-based diffusion to address this gap. Our initial step was to adapt diffusion transformers, DITs, from class to text conditioning, a process involving thorough empirical exploration of the conditioning mechanism. We then scaled GenTron from approximately 900M to over 3B parameters, observing significant improvements in visual quality. Furthermore, we extend GenTron to text-to-video generation, incorporating novel motion-free guidance to enhance video quality. In human evaluations against SDXL, GenTron achieves a 51.1% win rate in visual quality, with a 19.8% draw rate and a 42.3% win rate in text alignment, with a 42.9% draw rate. GenTron also excels in the T2I comp bench, underscoring its strengths in compositional generation. We believe this work will provide meaningful insights and serve as a valuable reference for future research. Beyond surface probing LLaMA across scales and layers, this paper presents an in-depth analysis of large language models, LLMs, focusing on LLaMA, a prominent open-source foundational model in natural language processing. Instead of assessing LLaMA through its generative output, we design multiple-choice tasks to probe its intrinsic understanding in high-order tasks, such as reasoning and computation. We examine the model horizontally, comparing different sizes, and vertically, assessing different layers. We unveil several key and uncommon findings based on the designed probing tasks. 1. Horizontally, enlarging model sizes almost could not automatically impart additional knowledge or computational prowess. Instead, it can enhance reasoning abilities, especially in math problem solving, and helps reduce hallucinations, but only beyond certain size thresholds. 2. In vertical analysis, the lower layers of LLaMA lack substantial arithmetic and factual knowledge, showcasing logical thinking, multilingual and recognitive abilities, with top layers housing most computational power and real-world knowledge. HyperDreamer, hyper-realistic 3D content generation and editing from a single image. 3D content creation from a single image is a long-standing yet highly desirable task. Recent advances introduced 2D diffusion priors, yielding reasonable results. However, existing methods are not hyper-realistic enough for post-generation usage, as users cannot view, render and edit the resulting 3D content from a full range. To address these challenges, we introduce HyperDreamer with several key designs and appealing properties. 1. Viewable. 360-degree mesh modeling with high-resolution textures enables the creation of visually compelling 3D models from a full range of observation points. 2. Renderable. Fine-grained semantic segmentation and data-driven priors are incorporated as guidance to learn reasonable albedo, roughness, and specular properties of the materials, enabling semantic-aware arbitrary material estimation. 3. Editable. For a generated model or their own data, users can interactively select any region via a few clicks and efficiently edit the texture with text-based guidance. Extensive experiments demonstrate the effectiveness of HyperDreamer in modeling region-aware materials with high-resolution textures and enabling user-friendly editing. We believe that HyperDreamer holds promise for advancing 3D content creation and finding applications in various domains. PhotoMaker. Customizing realistic human photos via stacked ID embedding. Recent advances in text-to-image generation have made remarkable progress in synthesizing realistic human photos conditioned on given text prompts. However, existing personalized generation methods cannot simultaneously satisfy the requirements of high efficiency, promising identity, ID fidelity, and flexible text controllability. In this work, we introduce PhotoMaker, an efficient personalized text-to-image generation method, which mainly encodes an arbitrary number of input ID images into a stack ID embedding for preserving ID information. Such an embedding, serving as a unified ID representation, can not only encapsulate the characteristics of the same input ID comprehensively, but also accommodate the characteristics of different IDs for subsequent integration. This paves the way for more intriguing and practically valuable applications. Besides, to drive the training of our PhotoMaker, we propose an ID-oriented data construction pipeline to assemble the training data. Under the nourishment of the dataset constructed through the proposed pipeline, our PhotoMaker demonstrates better ID preservation ability than test-time fine-tuning-based methods, yet provides significant speed improvements, high-quality generation results, strong generalization capabilities, and a wide range of applications. Our project page is available at project's website. Smooth Diffusion, crafting smooth latent spaces in diffusion models. Recently, diffusion models have made remarkable progress in text-to-image generation, synthesizing images with high fidelity and diverse contents. Despite this advancement, latent space smoothness within diffusion models remains largely unexplored. Smooth latent spaces ensure that a perturbation on an input latent corresponds to a steady change in the output image. This property proves beneficial in downstream tasks, including image interpolation, inversion, and editing. In this work, we expose the non-smoothness of diffusion latent spaces by observing noticeable visual fluctuations resulting from minor latent variations. To tackle this issue, we propose smooth diffusion, a new category of diffusion models that can be simultaneously high-performing and smooth. Specifically, we introduce stepwise variation regularization to enforce the proportion between the variations of an arbitrary input latent and that of the output image is a constant at any diffusion training step. In addition, we devise an interpolation standard deviation (ISTD) metric to effectively assess the latent space smoothness of a diffusion model. Extensive quantitative and qualitative experiments demonstrate that smooth diffusion stands out as a more desirable solution not only in T21 generation, but also across various downstream tasks. Smooth diffusion is implemented as a plug-and-play smooth LoRa to work with various community models. Code is available at the project's website. DreamVideo, composing your dream videos with customized subject and motion. Customized generation using diffusion models has made impressive progress in image generation, but remains unsatisfactory in the challenging video generation task, as it requires the controllability of both subjects and motions. To that end, we present DreamVideo, a novel approach to generating personalized videos from a few static images of the desired subject and a few videos of target motion. DreamVideo decouples this task into two stages, subject learning and motion learning, by leveraging a pre-trained video diffusion model. The subject learning aims to accurately capture the fine appearance of the subject from provided images, which is achieved by combining textual inversion and fine-tuning of our carefully designed identity adapter. In motion learning, we architect a motion adapter and fine-tune it on the given videos to effectively model the target motion pattern. Combining these two lightweight and efficient adapters allows for flexible customization of any subject with any motion. Extensive experimental results demonstrate the superior performance of our DreamVideo over the state-of-the-art methods for customized video generation. Our project page is at project's website. Controllable human-object interaction synthesis. Synthesizing semantic-aware, long-horizon human-object interaction is critical to simulate realistic human behaviors. In this work, we address the challenging problem of generating synchronized object motion and human motion guided by language descriptions in 3D scenes. We propose controllable human-object interaction synthesis, COAS, an approach that generates object motion and human motion simultaneously using a conditional diffusion model, given a language description, initial object and human states, and sparse object waypoints. While language descriptions inform style and intent, waypoints ground the motion in the scene and can be effectively extracted using high-level planning methods. Naively applying a diffusion model fails to predict object motion aligned with the input waypoints and cannot ensure the realism of interactions that require precise hand-object contact and appropriate contact grounded by the floor. To overcome these problems, we introduce an object geometry loss as additional supervision to improve the matching between generated object motion and input object waypoints. In addition, we design guidance terms to enforce contact constraints during the sampling process of the trained diffusion model. Hierarchical spatio-temporal decoupling for text-to-video generation. Despite diffusion models having shown powerful abilities to generate photorealistic images, generating videos that are realistic and diverse still remains in its infancy. One of the key reasons is that current methods intertwine spatial content and temporal dynamics together, leading to a notably increased complexity of text-to-video generation, T2V. In this work, we propose HyGen, a diffusion model-based method that improves performance by decoupling the spatial and temporal factors of videos from two perspectives, that is, structure level and content level. At the structure level, we decompose the T2V task into two steps, including spatial reasoning and temporal reasoning, using a unified denoiser. Specifically, we generate spatially coherent priors using text during spatial reasoning, and then generate temporally coherent motions from these priors during temporal reasoning. At the content level, we extract two subtle cues from the content of the input video that can express motion and appearance changes, respectively. These two cues then guide the model's training for generating videos, enabling flexible content variations. and enhancing temporal stability. Through the decoupled paradigm, HyGen can effectively reduce the complexity of this task and generate realistic videos with semantics accuracy and motion stability. Extensive experiments demonstrate the superior performance of HyGen over the state-of-the-art T2V methods. Gen 2 Det, Generate to Detect. Recently, diffusion models have shown improvement in synthetic image quality, as well as better control in generation. We motivate and present Gen 2 Det, a simple modular pipeline to create synthetic training data for object detection for free by leveraging state-of-the-art grounded image generation methods. Unlike existing works which generate individual object instances, require identifying foreground followed by pasting on other images, we simplify to directly generating scene-centric images. In addition to the synthetic data, Gen 2 Det also proposes a suite of techniques to best utilize the generated data, including image-level filtering, instance-level filtering, and better training recipe to account for imperfections in the generation. Using Gen 2 Det, we show healthy improvements on object detection and segmentation tasks under various settings and agnostic to detection methods. In the long-tail detection setting on LVICE, Gen 2 Det improves the performance on rare categories by a large margin, while also significantly improving the performance on other categories. For example, we see an improvement of 2.13 box AP and 1.84 mask AP over just training on real data on LVICE with mask RCNN. In the low data regime setting on COCO, Gen 2 Det consistently improves both box and mask AP by 2.27 and 1.85 points. In the most general detection setting, Gen 2 Det still demonstrates robust performance gains. For example, it improves the box and mask AP on COCO by 0.45 and 0.32 points. Efficient monotonic multi-head attention. We introduce the efficient monotonic multi-head attention, EMA, a state-of-the-art simultaneous translation model with numerically stable and unbiased monotonic alignment estimation. In addition, we present improved training and inference strategies, including simultaneous fine-tuning from an offline translation model and reduction of monotonic alignment variance. The experimental results demonstrate that the proposed model attains state-of-the-art performance in simultaneous speech-to-text translation on the Spanish and English translation task. Chain of code, reasoning with a language model, augmented code emulator. Code provides a general syntactic structure to build complex programs and perform precise computations when paired with a code interpreter. We hypothesize that language models, LMs, can leverage code writing to improve chain-of-thought reasoning, not only for logic and arithmetic tasks, but also for linguistic ones, and in particular, those that are a mix of both. For example, consider prompting an LM to write code that counts the number of times it detects sarcasm in an essay. The LM may struggle to write an implementation for detect sarcasm string that can be executed by the interpreter. Handling the edge cases would be insurmountable. However, LMs may still produce a valid solution if they are used not only to write the code, but also to selectively emulate the interpreter by generating the expected output of detect sarcasm string and other lines of code, for example, that the interpreter could not compile. In this work, we propose Chain of Code, CoT, a simple yet surprisingly effective extension that improves LM code-driven reasoning. The key idea is to encourage LMs to format linguistic subtasks in a program as flexible pseudocode that the compiler can explicitly catch undefined behaviors and hand off to simulate with an LM as an Emulator. Experiments demonstrate that chain of code outperforms chain of thought and other baselines across a variety of benchmarks. On Big Bench Hard, chain of code achieves 84%, a gain of 12% over chain of thought. CoT scales well with large and small models alike and broadens the scope of reasoning questions that LMs can correctly answer by thinking in code. Project webpage, project's website. NeRFiller, completing scenes via Generative 3D Inpainting. We propose NeRFiller, an approach that completes missing portions of a 3D capture via generative 3D Inpainting using off-the-shelf 2D visual generative models. Often parts of a captured 3D scene or object are missing due to mesh reconstruction failures or a lack of observations, for example, contact regions such as the bottom of objects or hard-to-reach areas. We approach this challenging 3D inpainting problem by leveraging a 2D inpainting diffusion model. We identify a surprising behavior of these models, where they generate more 3D consistent inpaints when images form a 2x2 grid, and show how to generalize this behavior to more than 4 images. We then present an iterative framework to distill these inpainted regions into a single consistent 3D scene. In contrast to related works, we focus on completing scenes rather than deleting foreground objects, and our approach does not require tight 2D object masks or text. We compare our approach to relevant baselines adapted to our setting on a variety of scenes, where NeRFiller creates the most 3D consistent and plausible scene completions. Our project's website is at Project's website. Pearl, a production-ready reinforcement learning agent. Reinforcement learning, RL, offers a versatile framework for achieving long-term goals. Its generality allows us to formalize a wide range of problems that real-world intelligent systems encounter, such as dealing with delayed rewards, handling partial observability, addressing the exploration and exploitation dilemma, utilizing offline data to improve online performance, and ensuring safety constraints are met. Despite considerable progress made by the RL research community in addressing these issues, existing open-source RL libraries tend to focus on a narrow portion of the RL solution pipeline, leaving other aspects largely unattended. This paper introduces Pearl, a production-ready RL agent software package explicitly designed to embrace these challenges in a modular fashion. In addition to presenting preliminary benchmark results, this paper highlights Pearl's industry adoptions to demonstrate its readiness for production usage. Pearl is open-sourced on GitHub at Project's website, and its official website is located at Project's website. Generating illustrated instructions. We introduce the new task of generating illustrated instructions, that is, visual instructions customized to a user's needs. We identify desiderata unique to this task and formalize it through a suite of automatic and human evaluation metrics designed to measure the validity, consistency, and efficacy of the generations. We combine the power of large language models, LLMs, together with strong text-to-image generation diffusion models to propose a simple approach called stacked diffusion, which generates such illustrated instructions given text as input. The resulting model strongly outperforms baseline approaches and state-of-the-art multimodal LLMs, and in 30% of cases, users even prefer it to human-generated articles. Most notably, it enables various new and exciting applications far beyond what static articles on the web can provide, such as personalized instructions, complete with intermediate steps and pictures in response to a user's individual situation. LEGO, learning EGOcentric action frame generation via visual instruction tuning. Generating instructional images of human daily actions from an egocentric viewpoint serves a key step towards efficient skill transfer. In this paper, we introduce a novel problem, egocentric action frame generation. The goal is to synthesize the action frame conditioning on the user prompt question and an input egocentric image that captures the user's environment. Notably, existing egocentric datasets lack the detailed annotations that describe the execution of actions. Additionally, the diffusion-based image manipulation models fail to control the state change of an action within the corresponding egocentric image pixel space. To this end, we fine-tune a visual large language model, VLLM, via visual instruction tuning for curating the enriched action descriptions to address our proposed problem. Moreover, we propose to learn egocentric LEGO action frame generation using image and text embeddings from VLLM as additional conditioning. We validate our proposed model on 2 egocentric datasets, Ego 4D and Epic Kitchens. Our experiments show prominent improvement over prior image manipulation models in both quantitative and qualitative evaluation. We also conduct detailed ablation studies and analysis to provide insights on our method. Scaling laws of synthetic images for model training. For now, recent significant advances in text-to-image models unlock the possibility of training vision systems using synthetic images, potentially overcoming the difficulty of collecting curated data at scale. It is unclear, however, how these models behave at scale, as more synthetic data is added to the training set. In this paper, we study the scaling laws of synthetic images generated by state-of-the-art text-to-image models for the training of supervised models, image classifiers with label supervision, and clip with language supervision. We identify several factors, including text prompts, classifier-free guidance scale, and types of text-to-image models that significantly affect scaling behavior. After tuning these factors, we observe that synthetic images demonstrate a scaling trend similar to, but slightly less effective than, real images in clip training, while they significantly underperform in scaling when training supervised image classifiers. Our analysis indicates that the main reason for this underperformance is the inability of off-the-shelf text-to-image models to generate certain concepts, a limitation that significantly impairs the training of image classifiers. Our findings also suggest that scaling synthetic data can be particularly effective in scenarios such as 1. When there is a limited supply of real images for a supervised problem, for example fewer than 0.5 million images in ImageNet. 2. When the evaluation dataset diverges significantly from the training data, indicating the out-of-distribution scenario, or 3. When synthetic data is used in conjunction with real images, as demonstrated in the training of clip models. Large language models for mathematicians. Large language models such as ChatGPT have garnered significant attention due to their capacity for general-purpose language comprehension and their ability to produce high-quality text or computer code. These models prove to be tremendously useful for various professions as they can enhance work quality and accelerate productivity. This note explores the extent to which these models can support professional mathematicians. To begin, we provide a mathematical explanation of the transformer model implemented in contemporary language models. Drawing from recent research, we then present recommended methodologies, potential concerns, and an examination of the mathematical capabilities of language models. Lastly, we highlight the potential impact of large language models on the practices of mathematicians.